So if we take a look, you can take it Thursday or Friday. Keep in mind, Thursday is the early release day. So I will, I actually should change that. I will be here for questions during the Zoom tomorrow. If you have any questions over anything, so I'm going to put optional, if I can spell, optional in class Zoom. If you don't need it and you want to go and make sure that you have the test, then go for it. As I said, you can take that test a maximum of 2 times. So if you're not happy with the first score, you may take it a second time. But keep that in mind. What that means is that all the math problems and stuff like that, they populate themselves with random numbers. So obviously it will not be the exact same test. It will be the same style and everything. But any answers that you had the first time may not be applicable the second time. All right. So yeah, I'm comfortable with that. If I'm not going to be there Friday, then since Thursday is shortened periods, then I have no problem with allowing you guys to have 2 days to take that. Cool. Questions about that? All right, then let's take a look at this review guide. Let me grab one real quick. So before I do this, let's go ahead and take a look, make sure we understand. So if we take a look here, this is the gas law answers to the packet. If you had any questions on the packet's answers, that's what that right there is. It's got all the answers to the packet. Versus this right here is the answers to this review guide. So you have all those answers available. Let's go through a few. I'll pick a few of them and we'll go through them. At SP, 1 mole of any gas has a volume of 22.4 liters. That's an important one. That's an important one. We've got to remember that if we have grams, we can find moles. So if we get moles, maybe they ask us for grams, but it says the 25-liter cylinder contains ammonia gas. They give us a temperature. What's the most important thing we do with that temperature? 32 plus 273.
It's 305.
We got to convert it to Kelvin. So with a pressure of this, that's our pressure. How many grams? If I want grams, I could get grams from moles. So if I know PV equals nRT, I want to solve for N, and then I want to convert it to moles after. Here's the V, here's the T, here's the P. We're going to rearrange this to solve for N. So the P, as I said, is 1.25 atmosphere. The V, 25.0 liters. R, since my atmosphere is pressure, it's 0.821 atmosphere liters per mole Kelvin. And the T, 305. Yeah. Huh. Let's try again. Yeah, right? All right. So 1.25 times 25 divided by 0.0821 times, if it's on bottom, we divide both times, right? 1.25 times 25 divided by 0.0821 divided by 305.
The answer is about 1.2479.
1.248 moles. They didn't want moles, they wanted grams of NH3. So we have 1.248 moles. Every 1 mole of NH3, well, we have 14.01 plus 3.03 for the 3 hydrogens. So that's 17.04. 1.248 times 17.04.
That would be about 21.2659.
21.3 grams, which our answer checks out. Questions there? Two. Yesterday we talked about the LA, the fart prank. We said if we spray this, the particle is quite big, so it moves through the room slowly. If you'll take a look here, we talked about how hydrogen would be the fastest. They actually say slowest to fastest, so hydrogen would be the fastest. Hydrogen has a greater speed than nitrogen, which has a greater speed than argon, which has a greater speed than chlorine. The way we did this is we looked up at the atomic mass for each. So this is 70.9. This is 39.95. This is 28. And this is 2.02. So the bigger the mass, the slower the speed. When a gas in an enclosed container is heated up, explain why its pressure will increase. Well, if we heat it up, the particles are moving faster. And collide with the ball more often. More collisions, more pressure. Whew. List the common properties of gases. We take a look. That's that molecular model or the collision theory. They are moving fast. Space between them is big compared to their size. That means they're compressible. And they are constantly colliding with everything in elastic relationships. So elastic relationships basically means that whenever they do collide, they don't gain or lose energy. constantly moving and colliding. What is the effect of increased collisions of gas molecules? Greater pressure. A gas's blank is a measure of the average kinetic energy of it. That is the temperature. At the same temperature, which has a higher velocity, helium or nitrogen? That would be helium because it's less massive. What are diffusion and effusions of gases? How they spread out, how they move throughout a container or room. Which gas molecules diffuse or infuse faster? Smaller ones. Smaller masses. Why? Because kinetic energy equals 1/2 mass times velocity squared. So if the mass is down, the speed must be higher. This is called Graham's law. Graham's law. What instrument do we use to measure atmospheric pressure? A barometer. Boyle's law states that oil is pressure and volume are inversely proportional. As one goes up, the other goes down. As one goes up, increases, the other decreases. Charles's law states that the temperature of a gas increases, its volume will increase as well. That means that they are directly proportional. If we increase the particles in a container, pressure will increase. If the container's volume is stagnant. We know this if we pump a tire up, even though the volume doesn't change much, the pressure inside gets bigger. If we put more particles in something like a balloon, the volume gets bigger. Standard temperature conditions are not 0 Kelvin, 0 degrees Celsius or 273 Kelvin, 1 atmosphere or 760 millimeters of mercury. Absolute zero is 0 Kelvin or negative 273 degrees Celsius. 125 degrees Celsius, 125 plus 273.
It's 398.
We add 273 to Celsius to get Kelvin. 100 minus 273.
That would be negative 173.
We subtract 273 to go from Kelvin to Celsius. Atmospheres to torr, 0.89 times 760.
It's 676.4.
We multiply atmospheres by 760 to get torr or millimeters of mercury. To go opposite, we divide. 1288 divided by 760.
It's about 1.6947.
1.69. The combined gas law is P1 V1 over T1 equals P2 V2 over T2. It has an initial pressure, volume, and temperature, and a final volume, pressure, and temperature. If one of the three variables does not change, then it cancels out. We drop it. When using combined units of P and V, must be blank and T must be in Kelvin. P and V must be the same on both sides. And temperature must be in Kelvin. If you don't do that Kelvin thing, it's wrong, 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 wrong. What is the molar volume of a gas at STP? That is 22.4 liters. The ideal gas law is PV equals nRT. It relates moles to pressure, volume, and temperature. R is called the ideal gas constant. For the ideal gas constant that we use, volume is in liters, pressure is in atmospheres, and temperature is in Kelvin. That is 0.0821. Grams of H2O to moles. Every 18.02 grams is 1 mole. 50 divided by 18.02.
That would be about 2.7746.
0.82 moles of neon. Every 1 mole of neon, that goes on bottom so moles cancel out, is 20.17 grams of neon. 0.82 times 20.17.
That would be 16.5394.
16.5 grams. Cool. All right, let's do a few of these problems right here. And we'll call it a day, and you guys can work on some of these on your own and then look at the answers. Consider a gas at 1 atmosphere in a 5-liter container at 20 degrees Celsius. What pressure does the gas exert when transferred to a 2-liter container at 43 degrees Celsius? So 273 plus this is 293. 273 plus 43.
The answer is 316.
That's 316. That's the first thing we need to make sure we do is get the kelvins. So here is our T1, here is our T2, here is our V1, here is our P1, and here is our V2. Right? I got that by looking and saying, oh, atmospheres, pressure, liters, volume. Second liters, second volume. Right? What is the pressure? So we take P1 V1 over T1 equals P2 V2 over T2. We want to solve for P2. So we divide both sides by T2, or multiply both sides by T2 and divide by V2. That cancels that out. And then we just need to plug everything in. 316 Kelvin. P1, 1 atmosphere. V1, 5 liters. V2, 2 liters. T1, 293 Kelvin. Notice Kelvin and liters will cancel out. We will be left with atmospheres. 316 times 1 times 5 divided by 293 divided by 2.
The answer is about 2.6962.
2.70 atmospheres. Hey, what's up? So if we take a look, that makes sense. 5 liters down to 2 would make the pressure go up. 20 degrees Celsius up to 43 would make the pressure go up. So the pressure goes up. Next one says a sample of ideal gas containing 0.954 moles is collected over 742 torr. That's the same as millimeters of mercury. And 31 degrees Celsius. 304. 31 plus 273.
It's 304.
So we have 304 for our temperature. We're trying to calculate the volume. So we need to divide both sides by P. So we have N is 0.954 moles. R, since we have this MMHG, what the R we need is actually not 0.0821. We could convert that 760 to atmospheres. Let's do that. 742 divided by 760.
That would be about 0.9763.
So I just changed that to atmospheres. Now I can use my 0.0821. Atmosphere liter per mole Kelvin. And last but not least, we need that temperature, which we found out to be 304 Kelvin. 0.954 times 0.0821 times 304 divided by 0.976.
The answer is about 24.3958.
24.40. 3 significant digits, 24.4 liters. Why is it liters? Because atmospheres, moles, and Kelvin all cancel out, leaving us with liters. All right. Cool. The only ones I don't see on here are the ones like the stoichiometry we did yesterday. So let's just make one up. Let's have a combustion reaction. I'm going to take carbon plus oxygen. I'm going to take methane. CH4 plus oxygen. That's a combustion reaction, which will give me carbon dioxide and water. I have 4 H's here, so I need a 2 here. 2 and 2, so I need a 2 there. This is carbon dioxide gas. This is gas as well. So I'm going to assume that this is at STP. And I'm going to take 24.0 grams of O2. I want to know how much carbon dioxide can be made with that. And I want it in grams. So we start with 24.0 grams of O2. Oxygen is diatomic, so that's 32 grams. Is 1 mole. Every 2 moles of oxygen makes 1 mole of carbon dioxide. Right? Actually, let's do liters, not grams, liters. Since we are at STP, every 1 mole of CO2 is 22.4 liters of gas. That's that molar volume if you did that gas law lab. 22.4. 24 divided by 32 divided by 2 times 22.4.
It's 8.4.
That will make 8.4 liters of gas. Cool. I think that's all I got for today. It's better for you to practice than watching me do problems. You do have the answer sheets for that, so check those out. If you do have questions, I will be in this Zoom or whatever, sticking around. But I got some other things I need to work on. But as I said, if you need these answers, you can get them here. Thanks. Have a great day. Don't forget, you have to take the test either Thursday or Friday. Tomorrow is a shortened day, so you may not have time if you're going to do it during this period tomorrow. Take care. Whoa.